Hi folks, we're going to take a look at number 15 from page 333. So they give us a bunch of information about these vectors A and B. So they give us the magnitudes of the individual vectors, and they give us the magnitude of the sum of the two vectors, and they want us to determine the magnitude of the difference. Okay, so one thing I notice here is there's no information about direction, but I do notice that I'm given information about the sum, and I'm looking for information about the difference. And there's a setup that we have for the sum and difference of two vectors in which there's a connection between them. And of course, that's our parallelogram display. All right, so that's what I'm going to do is set up a parallelogram. And we know that this represents one of the diagonals and this represents the other diagonal. Okay, so let's start by setting it up. And I'll try to draw the diagram kind of big here. So let's say this is the vector A. And then here, this is the vector B, okay, a little longer. Okay, so this has a magnitude of 3, and this has a magnitude of 5. All right. And of course, we know that, let's use some different colors here. We know that the sum of these two vectors represents the diagonal from the two tails. Okay, so let me just sort of try to redraw that vector A on the other side. So this is going to represent the sum. Okay, so this is going to be the magnitude of A plus B, which is equal to 7. All right. And then we have the other diagonal, okay, between the two tips, which represents the difference. All right, so since it really isn't going to make a difference here since we're just finding the magnitude, but we might as well draw it correctly. So if we're doing A minus B, it goes from the tip of the second to the tip of the first. Okay, so this vector here represents the difference A minus B, and we're looking for the magnitude. All right. So we see that both of these form a triangle with these side lengths that are given of 3 and 5. So let's just figure out how we can connect them. And we've seen this quite a few times before, and the connection is going to be with respect to particular angles. Okay, so this angle here, which I'll call theta, represents the angle between the two vectors because that's where they're placed tail to tail. But because this vector, when I shifted it over, is parallel to that one there, we know that this angle, which I'll call phi, is just supplementary to that one there. So theta is just going to be equal to 180 minus phi. I wrote it this way because this is the one that I can actually calculate because I have all three sides of this triangle. So here, this side here is the same as that one there. So that's 3. So 3, 5, 7. I can use the cosine law to find that angle phi. All right, so let's go ahead and do that. So we have phi is going to be equal to cos inverse of, well, its opposite side length is 7. So that's what we're going to start off with here. So 7 squared minus 3 squared minus 5 squared all over -2 times 3 times 5. All right, so let's calculate that here. So cos inverse, open the bracket for the numerator. So 7 squared minus 3 squared minus 5 squared divided by -2 times 3 times 5. Okay, and what do we have? We have exactly 120 degrees. So the angle theta, the one, oops, sorry, I already found that one. The angle theta is just going to be 180 minus 120. So 60 degrees. Okay, now why is that important? Because now I have in this triangle which contains the difference of the two vectors, which is what I'm looking for, I have the other two sides and I have the angle across it. So I could use cosine law a second time. All right, so in order to find the magnitude of A minus B, I'm just going to use cosine law on that triangle. So that's just going to be the square root of the square of the other two sides. So 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of the angle, okay, across that length, which is just 60 degrees. Okay, and that's it. This is going to give us our answer. So let's calculate that here. So square root of 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60. and that's equal to 4.36 approximately. All right, so in the end, the trick to solving this problem was recognizing that we should set up a parallelogram in order to make use of the fact that there's a relationship between the sum of the vectors and the difference of the vectors. In other words, they give us the two different diagonals. And of course, the main thing that helps us do this is that once I found this angle within the sum triangle, I was able to find this other angle in the triangle that contained the difference. Okay, that's it for this one.